So we're adding on to yesterday's notes. Go ahead and title it Area Day 2. And to begin, we're going to need to draw a rather complex graph. Okay? I need you to go out 4 marks in each direction on the X and 3 on the Y. Any point that is not on an axis, I'm going to label so that you know exactly where it is. We're creating a piecewise function here. Because, yeah, I do it fast because I am copying something. I've already got it down on paper, so it doesn't take me long to draw. And I've already done it twice other times today. If you're watching this video, pause the video and finish drawing. All right. What we are going to do is use the geometry and the properties under these curves on specific intervals. So, part A, here's our first problem. I want to do the integral from 1 to -1 of f of x dx. The integral from 1 to -1 of f of x dx. I want to have a more in-depth area today to make sure you really understand what I'm talking about. Okay, so are these A and B, or limits of integration numbers, in the correct order? Am I going from the smallest to the biggest? No. This is saying I want to go from 1 to -1. That's considered backwards. That's considered negative area. So you can tackle it 2 different ways. The most common way is to switch them, like that first property said, put the -1 on the bottom and the 1 on the top, and just put a negative out front to remind yourself it's negative area. So this was that first property from the last set of notes. If you switch the A and the B, you put a negative out front, and that reminds you that it's negative area. Okay? So now, from -1 to +1, what kind of shape are we talking? A semicircle. So the formula would be 1/2 pi times r squared. What's r in this case? The radius is 1, but don't forget the negative. So the answer would be -1/2 pi. All right, letter B. The integral from 0 to 4 of f of x dx. You have got to get to the point, if you're not there already, that when you see something like this, you know that means I want the area under the curve from 0 to 4. Okay? Now, looking at the picture from 0 to 4, are you seeing one distinct geometric shape? Is it from 0 to 4? Is that one shape? No, it's really 2. Where does it change from one to the other? 1. At 1. So what we're going to do is we're going to break this into 2 separate integrals. One that goes from 0 to 1, and the other one goes from 1 to 4. Because one will be the one shape and one will be the other. So on the next line, we're going to write the integral from 0 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. And this is kind of that 5th property in reverse, because the 5th property said if you take this one and then you go the rest of the way, you get the full area. We're just breaking it apart so we can do the math. Okay? 0 to 1 shouldn't be very hard because we've already looked at that in part A. So if this whole semicircle was 1/2 pi, this one would be 1/4 pi. Would it be positive or negative? It's positive because you're going from 0 to 1. Okay. Now, here's where it gets a little interesting, and I need you to listen very carefully. Okay? Look from 1 to 4. Okay? I'm going to cover up this right here so you can see what I'm talking about. The definition of this is area under a curve. Here's the curve, or line in this case. If I went under it, that would be infinite, wouldn't it? So in reality, I'm really talking about the area of the triangle, which is over it. So this area, because this triangle is under the x-axis, is also considered negative area. Okay? Now, listen to my question. Is this part of the graph, is this a positive piece of graph right here? Do you remember the distance between positive graph and negative graph? Just graph itself? This part of the graph is positive because it's above the x-axis, right? This part of the graph is negative because it's below the x-axis. So, negative graph creates negative area. Are you following what I'm saying? Okay. So, when we do this, if you just think of your height as a negative because you're going down, it'll take care of the negative that you need for your negative area. So, the formula for the triangle is 1/2 the base times the height. How long is that base right there?
3.
It is 3 units long. And the height, because it's going down, we're going to call it -1, and that will create the negative area that I want. So the final answer will be 1/4 pi minus what? 3 over 2. That's considered the final answer. The most accurate answer. The quarter circle right there. The area from 0 to 1. Questions? Okay, part C. Do you have a question? Okay. Letter C. The area from -3 to -1 of f of x dx. Or the integral from -3 to -1 of f of x dx. Okay, while you write that down, I'm going to manipulate my paper so you can see both what I'm writing here and the graph at the same time. So hang on just a second. There. Okay. Are these limits of integration in the correct order? Are these right, quote unquote, or do I need to switch them around? They're right. Smallest is on the bottom, biggest. So we are talking about a, what shape? Triangle. So 1/2. How long is its base? 2. What is its height? 2 again. So the area would be 2. Now, some of you may be thinking, well, do you have to write that unit squared? The answer is if they don't specify in the AP exam a specific amount of units, you don't have to necessarily write the units. If you write them, great. If you don't write them, they're not going to take points off. But if they say that it's if it's in meters or something, then you need to put square meters. Okay? So that takes care of that. Letter D. The integral from -3 to -4 of f of x dx. The integral from -3 to -4 of f of x dx. Do I need to switch these limits of integration?
Yes.
Yes, I do. So I'm going to write a negative, put my integral, and switch them. Okay. Now we have an interesting thing happening. From -4 to -3, I'm going to draw just a dotted line perpendicular here. What kind of shape are we talking about? Triangle. What's unique about that triangle? It's a right triangle and it's below the x-axis. When something's below the x-axis, what did I tell you about its area? It's negative area, but I already have a negative. So it's positive area. It's positive area. Because it started out going backwards, but it's below the x-axis. It's like saying, I ain't not going to do something. You know, it's a double negative, which makes a positive in this case. Ain't not, yes. Listen to my English. So we write negative 1/2. The base is 1. Write the height as a negative because you're going down. That would be negative 3. So the final answer would be positive 1.5. Or 3/2, whichever you prefer. Questions? Okay, I only have one more and then we're done. Okay. This one has been on the AP exam also, and a lot of people miss it, and it's so easy. So let me show it to you. Integral 1 to 4 f of x plus 3 dx. The integral from 1 to 4 of f of x plus 3 dx. There's at least 2 of these on your worksheet, I can guarantee it. I know there's one on the front. When you have a function with a number added to it. Usually when you add a number to a function, it moves the whole function up that many. But we're not going to redraw this thing 3 units higher. That's too hard. We're going to figure it out without having to do that. Okay? So what we're going to do is we're going to break this into 2 separate integrals, because I know what 1 to 4 of just f of x is, because this right here, I forgot to write it initially, that is f of x. And then you write a separate one for the 3, like so. Now I'm going to scoot this up higher because 1 to 4 is over. Have we already done 1 to 4? Did we already find the area from 1 to 4? What was it? Negative 3/2. Okay. This right here is a geometric shape that is not even on that graph. This is going back to the beginning of the notes from last class. Find the area from 1 to 4 underneath the graph of 3. What's the graph of 3 look like again? Horizontal line. Right there. So I want to find the area from 1 to 4 under that line.
Like Math 9?
No, actually, this is no calculator.
But
you could do it on Math 9, yes, yes. Okay, so what's the base on this rectangle? 3. What's the height? 3. So the area would be 9.
So it's actually a square.
It's actually a square, yes. So what that means is, let me explain it to you pictorially. Remember I told you that this means I'm taking that funky looking graph and moving it up 3. What this tells me is if I moved it up 3, I'm adding 9 more square units of graph to it. Okay? Without having to redraw the graph. So now I get a final answer. What is 9 minus 3/2? 7.5. I thought somebody said 7/2. No, 7.5 or 15/2. So what do I want you to remember? I want you to remember that if you ever have a number added to the end of a function that you're trying to find the area, separate it off and do it as its own geometric shape. Okay? Because you will see that on the homework. Any questions?